Hey, so in this video, we're going to be talking about work. Now, work is the amount of force needed to move some distance. And we have two different types. We have force that acts along the line of motion, kind of like a rocket propelled up. And then we also have force acting at an angle with our line of motion. Think of pulling some kids in a wagon. Here that force is pulling up on the handle as well as pulling forward. When our force acts along the line of motion, we can say that our work is going to be the magnitude of our force times the distance, like so. But if our force is moving at an angle with the line of motion, then that means we're going to need to figure something else out. Now, because we're pulling up and moving forward, what we've actually created here is a right triangle, right? And so here we're able to use our work formula where we'll be taking the magnitude of the projection of F onto our PQ times the magnitude of our vector. But if we take a look at that, at the right triangle that we've made, and we can see that we have this angle theta here. If we take the cosine of that, that tells us that the cosine of that theta is the magnitude of the projection of F onto our vector divided by the magnitude of F. And if we kind of rearrange that a little bit, then that gives us this helpful little hint down here where we'll be able to say that the projection of F onto PQ is the cosine of theta times the magnitude of F. And we see that we have here the alternate form of the dot product, which then allows us to substitute in for the projection of F onto PQ this cosine of theta times F, which again is really just the alternate form for the dot product of our force and the dot product of vector PQ. So our equation here on the left is really just the projection form, while our equation here on the right is simply our dot product form. So really, either of these equations will work, and they'll work for either the force acting at an angle theta with a line of motion, or you can even use them for the force acting along the line of motion. You can also use our W equals the magnitude of F times the magnitude of PQ for that as well, though. And so that's how we can figure out our work, or the amount of force needed to move some distance.